একটু ওয়েট করে নেব, কিছু পার্টিসিপেন্টস আসুক।
Okay.
একটা কমেন্ট লিখে দাও যে মেসেজটা করুন।
How many are there?
আচ্ছা,
Okay, good evening to everyone. So, and good morning to Professor Ganguly. So, we are so happy to have you in this meeting, and we are eagerly waiting to follow your lectures on the sessions. So, as an introduction, let me just tell you briefly that Professor Ganguly was an ex-student of Vivekananda Mission School and Assembly of God Church School and Kharagpur IIT. After that, he did his master's and PhD in Washington State University. And from the year 2010, he is working as an assistant professor, then associate professor, then HOD in Rochester Institute of Technology, USA. He's very pioneer in research arena, and what I have gathered information that his area of interest is energy efficient NOC, multi-core architectures, and he is doing a very good job in this area. He has got a number of research papers, and he is leading his present team of professors in RIT, as well as he is serving a lot for the youngsters. And we are so happy that today he has given some valuable time of his busy schedule to share his experience, his journey of education, his struggle, his all the thought process, what he has gathered in so many years, and he would like to share all these things with you. So we hope that you will get a lot of benefits from it. So listen it carefully and enjoy the session. So now I invite Professor Ganguly to start his speech.
Thank you, Tribedi sir. First of all, I must thank you, and I must thank all your students who are in the session today. It's a distinct privilege and honor to talk to young students all the time. I really enjoy doing that. That is the reason that we are teachers wherever we are. It is a very exciting experience to talk to students all the time. So I'm going to, like Tribedi sir mentioned, I'm going to talk briefly about what I do and some of my own background, but I'm really looking forward to and excited about a question answer session where I can answer any questions about my own career or your career, etc., that come to your mind. So without much delay, let's get started. So I want to share my presentation with you. So let's see. Okay. So I hope you can see my screen. Sir, if you see any issues, let me know. I'm going, and so after I'm done with the presentation, I will come back and I can watch the online platform again. So if there is any chat or anything in the meantime, I will come back to it when I'm done with the presentation. So with that, this is my current position. I am department head of computer engineering at Rochester Institute of Technology in the state of New York in USA. And I'm going to give you a brief overview of the department and what computer engineering is as such, and how it is subtly different from other disciplines like, say, computer science or electrical engineering, electronics engineering, and so on. Just to give you some context. So, what is computer engineering? Computer engineering is a very broad discipline. It encompasses various kinds of computing systems, all the way from devices, very low level, small miniature devices such as transistors or semiconductor devices, to even information processing. So it is very hard to define such a broad field, but largely you can think of this field as engineering computing systems. Um, of all kinds, not just computers, laptops, or desktops, but computers from the smallest embedded systems that go inside, your handheld devices like phones, to data centers, which are, kilometer scale, warehouse scale computing infrastructure. Of course, this requires design and creation of both hardware and software, and we learn by doing things, and the key is to have a creative mind and open-ended attitude towards the design process, learning from different fields, applying and creating new knowledge. So you can see here this nice picture, which, let me go to my pointer. Yeah, so on the left side here you see electrical engineering, and on the extreme right you have computer science. Computer engineering has overlap with both these disciplines. So electrical engineering deals with, basics of electricity, operation and creation, design of machines, motors, some analog kind of devices which are, which interact with the outside world. And then the overlapping part of electrical engineering with computer engineering is digital circuits and digital electronics. And then in computer engineering, the core of computer engineering is creating hardware software integrated systems, where we develop the system platform, all together with both hardware and software. And the part that overlaps naturally with computer science is programming and algorithm creation. And some abstract aspects of computer science, such as abstract mathematics and high-level abstraction, these kind of things we don't do as much. But of course, the boundaries here are very blurred. Unfortunately, there are computer engineering faculty and researchers who do really high-level abstract algorithms, and there are computer engineering researchers who deal with analog devices, etc. Including myself, I also do that sometimes, not all the time. That's not my bread and butter, but I have to do it because this world is increasingly interconnected. One discipline blends into the other, and as you will see later on in a few slides, it's very really hard to stay within your own silo and just isolate yourself from the rest of the things that are going on. So you have to interoperate across disciplines, interoperate across industry, and so on. So these are very rough sort of guidance, and by no means are defining boundaries. So other examples, and I think that we can take examples of what computer engineers do to understand, rather than looking for an abstract definition. This is here. You see, on the left, this picture is that of a microprocessor chip, and these are pictures of a supercomputer and a data center, right? So computer engineers design all of these things. So from the tiniest microchips to the largest data centers, you will find computer engineers, computer scientists, electrical engineers, doing these kind of things. Again, robotics, embedded systems for robotics, where you design moving parts and give them intelligence so that they can execute some tasks on their own, things like that. Then there is networking and communications. Computers nowadays or even phones cannot work in isolation. They need to be communicated or connected with other such nodes. So how do you create large scale networks? How do you make communications reliable and secure? These are important things. Autonomous vehicles, you know all about the Tesla and all of those kind of companies, the Google car. So automobiles used to be a mechanical engineering product, up to about 10, 20 years ago. But now most of the work that happens in automobiles is in automating and autonomous driving. So again, this is very much related to computer engineering, computer science, artificial intelligence, and all these kind of things. So the innovation in even in a traditionally mechanical engineering kind of discipline, the innovation now happens more and more in computer engineering kind of things. And there is big data. There is so much data we are creating. All our phones actually are sensors. They're gathering information at an unprecedented rate. Then there are IoT kind of sensors that are creating all sorts of sensing all different kinds of things like weather and everything that you can possibly imagine. And these petabytes of data need to be stored, processed, and decisions need to be made based on this. So cloud computing, big data analysis, these are important parts. And as you can imagine, large scale algorithms, data science, etc., is related to these kind of things, which again, computer scientists and computer engineers do. Internet of Things, connected sensors, your smart glasses, your phones, your healthcare monitoring, smart healthcare monitoring systems, smart homes, smart infrastructure, smart cities. What does all this mean? It means that every component of your city or your home will have some kind of sensors that are going to keep a track of how things are being used, the reliability, the level of integrity of these elements, and report back to a processing element that then issues some alerts or issues some direction so that actions can be taken either automated or by human intervention to fix any problems or to improve reliability, to improve efficiency of these kind of systems. And they can range from very like a smart building to a smart city, to an interconnected smart world. Again, cyber physical systems, this is the same thing, but they're different terminology is used, and I'm throwing these terminologies at you because you need to be able to speak in this language when you talk to experts as well, right? What are cyber physical systems? They are kind of like smart infrastructures. You can think of a smart city or a smart agricultural space, smart farming, where you have drones that go monitor the watering system, or how dry or how wet your particular patch of your agricultural field is. And then if it recognizes that it needs more watering, it gives more water, or it recognizes that it is too wet and it needs to dry out, so it steps back on the irrigation. Things like that, you can imagine, everything like this is automated. And our computer engineers work in these kind of areas. Of course, not to mention machine intelligence, making all these systems smart and autonomous to a degree. That means human intervention is less and less required so that the human time can be used productively elsewhere, in things that machines cannot do, right? So sensing, processing the data, recognizing the data, understanding the scenario, and reacting to these kind of scenarios. This is basically what is machine intelligence. So in short, computer engineers, design hardware and software for computer systems that, of course, target high performance, energy efficiency, and they are intelligent, they are reliable and resilient, they are sustainable. That means they do not burn through, your fossil fuels, and they are efficient. And of course, they need to be interconnected because they need to interact with other such systems. So this is kind of overview of my department. We have about 450 undergraduate students and maybe around 50 more now. This is a little updated information. Graduate students. So we have about 500, 550 total students in the department. This was established, the department itself was established in 1975. As you can imagine, computer engineering in 1975 was a very, not too many places had a separate computer engineering department. So it is one of the earliest and pioneering departments in that area. We have 13 full-time faculty and some other adjunct faculty who visit and teach special courses, and we have some staff members to help us. Our core areas that we work in are advanced computer architectures, digital IC and nanosystems design, networks and security, computer vision, machine intelligence, and embedded systems and signal processing. And we have many PhD programs, etc., besides just bachelor's and master's programs. Um, and these are some research labs that we have. We have nanocomputing brain lab, multi-core systems lab, which is my research lab. Then we have cryptographic engineering lab, which deals with security of data. We have high performance architecture lab that deals with GPUs, kind of advanced processors. Then we have real time and image processing lab, which is a computer vision, machine intelligence kind of lab. Then we have networks and information processing lab, which is a communication kind of thing. And then we have machine intelligence and artificial intelligence labs. So this is a snapshot of some of my research projects, my own research projects. So I work in an area, in a project that we can call a smart warehouse. So you can imagine the Amazon or the Alibaba warehouse, where you have robots and fork trucks. There's one picture here. My students are working on automating a forklift that goes around, these aisles of warehouses, lifting big boxes and pallets of boxes and moving them around to shipping them and so on. So part of the work that I do there is helping with the localization of these robots and communication of these robots with other robots, making decisions and so on. Another very exciting project I do is in-memory processing. So it's a different kind of a processor compared to our traditional CPUs. Instead of bringing data from memory to the CPU to process, it's designing a processor inside a memory. So this is a very exciting project that we do in collaboration with the Air Force Research Lab in the US. Mostly targeted towards encryption kind of data security applications or artificial intelligence kind of applications. My bread and butter sort of research has been multi-core processor architectures with hundreds of cores in them and requiring on-chip networks or networks on chips, NOCs. And I've looked at on-chip communication using wireless interconnect, on-chip communication using photonic interconnects, and so on. So these are very exciting projects. I've worked on them for the last 15 years or so. About the last 5 years, I've also looked at data center. So how to make data centers more efficient, how to do better and more efficient computation and communication within a data center. Yep, these are some of the highlights of our activities until 2020. So we won a Best Paper Award on our Smart Warehouse project in a conference that is part of CES. Some of you may know, Consumer Electronics Show is an annual kind of show where all the new electronics gadgets are announced, from all the companies like, Intel, Apple, Google, and so on. So our paper there of designing a smart robot warehouse won the Best Paper Award in the academic conference of that show, which is called ICCE, International Conference on Consumer Electronics. We also have we have published about 100 papers so far on these various projects. So that's also very exciting for us. A little bit about my own career path, which might be interesting to some of you as you are in high school. Near, I don't know which classes you are in, but assuming that you were in a school, so this is where my journey started. I met Tribedi sir in Vivekananda Mission School many years ago now. I think I finished school in 1999, probably before some of you were born. And then I went to do my bachelor's in IIT Kharagpur from 2001 to 2005. Very beautiful 4 years of my life. Then I went to do my graduate school, that is my master's and PhD in Washington State University in Washington State near Seattle. And then I started as a faculty member, as a professor at RIT in 2010. From 2010 to 2015, I was an assistant professor, and then in 5 years, you kind of go through a promotion process, after which I became an associate professor. And then as things happened in 2018, there was an opportunity to become the department head, and I got selected to lead the department itself, the Department of Computer Engineering at RIT. It's a lot of hard work, but so far so good. I'm enjoying and learning my new roles as department head as well. in addition to doing my research, which is very near and dear to me, as well as teaching. So to give an overview, to recap, in my school days, I really liked subjects like physics, and you wouldn't guess this, history. Physics, mathematics, history used to be my favorite subjects, and computer science was an elective which I took with Tribedi sir. And the interesting thing about the funny thing about me then was I was a little scared about computer science, and I really could not understand how writing code could make a computer react. But those were many years ago. Now you guys are way smarter than I was in my school days. So, but Trivedi sir helped me a lot. I think taking tuitions with him, I must say that my fear actually went away, and I started to understand how to write code better. And that probably, I should say, is the start of my, familiarity with computers, no doubt. But back then we used to write program. I forget. I think it was a basic language. I think the language that was called was basic, not even C or C++. Um, but anyway, then I started my undergraduate days in Kharagpur, and then I really loved electronics and working with computers and so on. And then in Washington State University, I worked on making very large, complex microprocessors. And at RIT now, I work with data centers and smart environments like smart warehouses and so on. Um, so, in terms of what are some of the emerging fields in computer science or computer engineering that you should be aware of, I really think that some of the important fields are artificial intelligence, of course, and you don't need me to tell you, but I just want to reiterate that that is indeed the case. Artificial intelligence is going to be there in a very big way. It is kind of everywhere, right? So every computer algorithm or computer system that you use will have an element of artificial intelligence in them. And this could be, and they would require people who are experts in developing algorithms, in developing hardware. Artificial intelligence will morph into something that we know as deep learning, which is machine learning, but mimicking the brain and the depth of the neural networks in the brain. It's very hard to make a computer that is as complex as the brain, and we can talk at length about it itself. But the deeper the hardware gets, the better it starts to mimic the brain. That's the philosophy. Then there is the data science. Like I said, we are all storing and creating a humongous amount of data on every second now. I mean, we take pictures with our phones and high fidelity pictures with our phones. When I was your age, my phone barely was able to make a call. So we were transmitting speech signal at probably a few kilobytes per second, and now we are transmitting videos at hundreds of megabytes per second. So it's 6 to 9 orders of magnitude difference in the rate at which we produce data. So that data needs to be seen, processed, understood, secured, and maintained in a private manner, right? You don't want your data to be accessed by someone else. Then there is industry automation. My kind of like my smart warehouse project, where more and more repetitive tasks can be automated rather than done with human intervention. Um, Internet of Things, that is, in this largely connected world, there are small sensors everywhere that are, interconnected to a computer or a computing system. Edge computing. Edge computing refers to a computer paradigm where you have distributed hierarchy of computers. Back in the back end, you have a big cloud which can be a warehouse scale computer like a supercomputer or a data center or multiple of them. But then, as progressively you get closer to the user, you have smaller computers, smaller servers, but still quite fast. And then, right near the user, you have a mobile edge device like your phone or like a tablet that has very limited processing power, but is actually close to the environment that the user is in. So you have this hierarchical system of quick reaction on the edge or in the mobile node, but very large processing and storage capability in the cloud. And how you manage this kind of a computer architecture. This is also an emerging field. Cybersecurity, of course, all of this, the previous bullets needs to be secure and needs to maintain data privacy and so on, and against all sorts of attacks, not just programming or hacking attacks, but all different kinds of other threats. So these, in my opinion, are some of the very important emerging fields that you need to learn. Not all necessarily in your school level, but through your college and graduate education, you need to become experts in one or more of these fields to have a good, successful career in the future, next 5 to 10 years. So this is a picture of my research group from a few years ago. There aren't too many good photo opportunities we get, but especially with COVID, nobody's really physically meeting anyone. But these are some of my students. As you can see, there are many Indian students there, and all kinds of students, some girls, some boys, and so on. This is only a very small sample size of my students. But anyway, so I'm happy to answer any questions, and we can take the discussion in an interactive manner at this point. Once again, I want to thank Tribedi sir for giving me the opportunity to interact with all of you, and all of you also for listening to me. I'm going to stop sharing now so that I can look at the screen again.
Okay. Let me pick up. You got the questions in the chat box, no? Have you got the question in the chat box?
I can see them. Yes, I think in the comment I can see them.
Yeah, yeah. So I can pick up some of the questions which are very technical indeed.
Yes, if you
Okay.
can moderate some of the questions, that will be
Yeah, yeah.
excellent.
That's it. That's it. So here I'll just pick up the question. What is asked by Rituja Mitro, is student here in class 9. So she has to say that what is the scope of programming within space science? So she is interested in space science possibly, and what is the scope of space science, programming in space science? She wants to know.
Yeah, so I'm guessing what she's asking is how important is a skill like programming to, working in
Exactly, in
space
space
science.
science. Yeah.
Right. For example, something like working for an organization like NASA or even ISRO, let's say, in India. My answer to that is huge. Nothing can happen in this space involving computers with good programming skills. Often you will find many such, let's say rockets or spaceships or even aircrafts, they use, processors and processing platforms that are off the shelf. You can go and buy this hardware, right? But when you put them together, you have to program the whole system so that they work together and perform a specific function. Often you will get, these processors that are not fully designed by the seller. So things like FPGAs, I don't know if you know about FPGAs, these are programmable processors. So when you get a programmable processor, there are some advantages because they are low cost and they are also pretty good in performance. But you can procure them very quickly. But once you get them, you have to program them so that they do the processing job that you want them to do. So it depends on the kind of programming skill you have. There are different kinds of programming. So you can think of programming in a language like Python and Java, which is a very high level programming language, which does not need you to know about the hardware at all. The operating system of the hardware is capable of compiling and understanding that Java program or that Python program and doing the job. That's one sort of programming, very useful, particularly if you're working with AI, artificial intelligence sort of field. The next level, you can program in a language like C and C++, where you need to know and understand the basic hardware at a much higher depth. Because a language like C allows you to manipulate the memory directly. You can tell the computer that I want my data to be stored in a particular location in the memory. How that is useful is because you can then regulate how the memory works, and how quickly you can retrieve the data from the memory and those kind of things. That capability is not present in higher level languages like Python and Java. Even at a lower level, you can program in a language that is called hardware description language, or HDL. If you program an HDL, then what you do is you create hardware by using programming. So programming itself is a huge field. It spans across different levels of goals, what you are trying to do with your programming. So because of all this, it's the question is very, very interesting, but the answer is huge. But you can do different things as a programmer. You can create hardware as a programmer, you can manipulate hardware as a programmer, or you can simply have the OS take care of your program if you are a very high level language programmer. Does that answer the question?
Good, good. Okay. Incidentally, just let me add with it, or just my connection with this. Uh, in my MTech, my project was on FPGA. Okay,
Mm.
and I did some work of my own regarding the modification of routing algorithm of FPGA using VPR. There is one package. Okay, and as far as the data is there, so I got some excellent result. But as it happens that it is now closed in the thesis book only, I never took any initiative to publish it. Okay, so but my interest at that time, at least, was on FPGA routing and then working with FPGA circuit.
Sure, sure, yeah.
Anyway, so I'll just take next question from Priyam Ray. He's a student of Don Bosco,
I think,
Success.
yeah, we can do this, but I think we might have missed one question from Dept, where he's
Yeah,
asking
yeah,
what is the difference. But we'll come to that. Yeah, you
yeah,
can
yeah.
moderate. Yeah.
Priyam has got a technical question. He says that when working with microcontroller, is computer engineering involved with building code for the microprocessor, or does building the hardware circuit also fall under it?
Yeah, indeed, both actually, both of them. Yeah. So again, it depends. As when you work in the field or for a company as a computer engineer, you could be asked to do both, or one of them, depending on the scope of the project. You might have somebody else work as a counterpart on the software part or the code part, and somebody else work on the hardware part. But yeah, computer engineering, studying computer science, not so much, but computer engineering will enable you to do the hardware aspect as well.
Yeah, yeah.
Computer
Then
engineering, in
this,
some way, computer engineering in the US is a little bit similar to what we call electronics in India, if that helps you understand the mapping between the disciplines.
okay. Before coming to Devdipto's question, actually Devdipto has a number of questions. So he's very, very good student, and he is from your school VMS.
Oh, nice.
Okay. So, and he's very particular. So that's why he has got a lot of questions. So before coming to this question, I have a questions that is very general question.
Okay.
The problem which we are finding here, that students are they are very much pressurized with the content of study. And that we have got, most of us got a target of doing well in competitive exam, targeting IIT JEE to build a career. Now, I am working here with the kids for developing their coding skill. So, my query is that if someone is not very good in PCM, not very good, I mean good but not very good, and not able to crack IIT entrance or not able to get a good rank in JEE, so do they have, I mean, how by learning programming skill, how they can do well in life? I mean, what are the scope of the students in general, even if they do not do very well in the competitive exam?
Right.
Got my point?
Yes. Excellent question. Excellent question. And I'm going to try to answer this in a realistic manner.
Yeah.
Um, so there is an advantage to studying in a elite very good school like the IITs or whatever is the equivalent of IITs in the US, right? There is some advantage, there is no doubt. uh, and the advantages are sometimes real. For example, I studied with the best the best students of my generation in my college. They were extremely smart, and they are very capable. Many of them were better than me. I was better than some, and it's just how things are. And our professors were also very good. And after graduating from IIT, people normally accepted that I am a good student. I didn't have to prove myself in every step of the way. But it's very important to keep one thing in mind. In my batch in IIT from Kharagpur, there were about 600 students. In my batch, I think it's just 2 or 3 of us who are in the academia in the US out of the 600. So not all 600 became scientists. Not all 600 became masters of the universe, right? And the reason is manifold. Some just may not have the interest of doing something so competitive or so, whatever. Academia and becoming a professor has some shortfalls also. So not everybody may be interested in that. Many have found a job in the IT, the information technology sector, consultancy services like your typical, TCS and Infosys kind of job because they liked doing that and that was available to them. So the mix of careers that we found ourselves, and many went into management sort of things, so the mix of careers that I saw in my batch are not too different from the mix of careers you would see from other engineering colleges. On the other side, one of my most successful PhD students is actually graduated from a just a ordinary college, engineering college in Ghaziabad in UP. He's not a graduate from any of the IITs. In fact, most of my PhD students are actually not from any elite school. Another interesting thing, and they're very successful, and the way that we know that they're successful is not because I, as their advisor, is saying that they're successful, but they get best paper awards in this conference that I showed you. Abhishek Vashisht, his name is. He's the one who won the Best Paper Award in Consumer Electronics Show. He just finished his bachelor's from a college in Ghaziabad and then came to do his PhD with me. So, and the reason that I personally do not choose my students based on which college they come from, but rather on their hard work capability and their dedication, is because after I finished IIT, I went to study for my PhD in Washington State University, which is not an MIT, which is not a Harvard, which is not a Stanford, right? It is a good college, but it's not MIT. And so it kind of taught me that what you become in life is a function of your current hard work and your past hard work, not the label that you carry. The label has some advantages, but it cannot make or break you. So while physics, chemistry, maths is very important, because without learning physics, chemistry, maths to some degree, at some level of proficiency, I don't think you can progress too far, in the current world of electronics and computer science, because they teach you some skills that are necessary. But if you're not failing in them, if you're doing reasonably well, I think you will be successful regardless of whether you end up in the very elite IITs or in any decent, reasonably good engineering college. Because I think reasonably good engineering colleges, and I have my own friends who are professors there as well in these kind of colleges, I think they're doing a very good job, better now than ever in the past. And I think that the trajectory is on the rise. So if you go to a non-IIT engineering college in India, I think you have a very good shot at being successful in your career, whether in India or abroad, if you, whatever you want to pursue. Now, if you, for example, if you don't go to an IIT and if you go to another engineering college somewhere else, learn your computer science and such kind of things, do you have a chance at going for your PhD in MIT or Stanford? I think that is low. I'll be realistic here. I think that is low because those kind of schools only trust students coming out of very elite colleges across the world, not just from India. So from China, China is another country that produces a lot of very brilliant students. But from China, they're only looking for from 1 or 2 universities like the Tsinghua University or Beijing University and so on. So they don't accept students from all over, everywhere from China. Although we know that many Chinese students are really very good. So it's the same way. So some universities have a little bit of that elitist attitude, and some professors also have it. Some professors in not so elite universities also have that elitist attitude that I will not hire somebody who is not from IIT or equivalent colleges. But that's not universally true. There are people of all types, there are people of all shades. You just have to find the right fit for yourself. But having said that, I would say that a lot depends on your hard work and your continuous hard work. It's not just I work only hard in my 12th, I crack that IIT exam, I get into IIT, and then I give up studying. Many people have done it. My friends have done it. I almost did it. So but that's not what you can do. That's not what you can afford. You have to consistently work hard, be very disciplined in how you work hard, work hard every day for a for a disciplined amount of time. It doesn't have to be 24 hours, right? Even if you study very hard for 4 hours, you have to do 4 hours every day. And studying right before exams and not studying at all for the year, these are a sure pathways to failure. You may pass one exam, but your career is never going to be sustainable in the long run if you only study one day of a year. So these are some generic. I can go on talking about generic advice like this from my own life experiences, but these are some key things that I want to mention.
Okay, just I have one thing to just add. Probably we all know that nowadays there are at least two companies I know, Amazon and Google. They are propagating to delink qualification with the job. So I suppose that in near future we are going to find uh, that the college degree, the level of the college qualification may not be that much important in the IT world for procuring good jobs and job of that sort which people are dreaming for. So what I mean to say that going to a good uh, college or good university to get a good job is slowly, I think, decreasing, because if you see that Google has introduced few courses, they're saying that if you could complete that, then you are employable in Google. Otherwise, we will recommend you for any other type of job. So here, the problem of the present generation students, that they find that they will have to crack that difficult exam in +2 level so that they can build their career. And I constantly say that you try your best to crack it, but in case it is not happening, there is nothing to lose hope. You can continue with your normal sense and then you can do your normal study. And since I'm a person to involve in teaching the coding, so I am insisting them that to be very strong in code. And nowadays, you know that online platform Hackers Rank and all other things, they can prove their eligibility. So that is my point of view with the current students. I mean, not to stress them upon with these competitions. So
No, I agree. I think that's actually a very good suggestion. Those opportunities and those exams, students can and should take as they come along, but
mm,
their life and their future does not depend on it. That much I can tell you. No single exam can either make or break anybody's career. It is through consistent hard work over long periods of time that people become successful, not by doing well in a single exam.
right. Now I'll pick up the question from Dept. He has many questions. So just one question, that what is the scope of nanotechnology in India? Here's a broad level question.
Yeah.
Nanotechnology.
So that is something that I will start with a caveat. I am not entirely familiar with nanotechnology per se, particularly in India. There is a lot of scope in the US that I know, but I don't know so much about India. But I think there are some labs, particularly in the nanobiology field, that are, I think, doing well as far as I know. Um, but in nanotechnology per se for electronics, I don't think that it has picked up that much yet. Nanoelectronics, I would say. But I will admit that I don't know nanotechnology myself very well.
Okay. I have a question here from Sohini. She's a student of Pratt Memorial. And she has a question that she's asking uh, the difference between statistical AI and classical AI.
Um, so the difference is very subtle. AI, uh, a lot of AI actually, now in the modern sense, a lot of AI actually relies on statistics and statistical understanding of data. So, for example, in a very basic sense, you have some, let's say, in the months of summer, you have your temperature every day rising, your average temperature rising every day. So what you can do is you can perform a simple regression, whether linear or nonlinear polynomial regression, and you can say that, okay, if the temperature today is, uh, let's say 25 degrees Celsius, tomorrow it may be 26. So in some sense that is AI, but that is artificial intelligence or machine intelligence using statistics. Now this is a very simple example of a regression. If the regression becomes more complex, and if it involves even choosing whether to do a regression or not, and whether to do some sort of classification using, so this is kind of what is done in statistical AI. So that part is very closely related to data science as well, because these algorithms then blend and when adapted to scale up in size, they kind of become like data science. Classical AI is the notion that computers or artificial systems can perform or should work as the human brain. Um, Now, the way the nerves and the neurons work is they, in a very basic level, they store electrical charge. They receive electrical charge, and once they receive a certain threshold, they propagate that charge to the next nerve cell. Right? It's accumulation and an activation. So if you build computers using that model, you have processors that are adding numbers that represent charge, and then once they compare it with a threshold and it goes above a threshold, they propagate that charge to the next computing node, right? Or the next circuit. So, so if you build computers like that, that's kind of like that mimics how the brain works, and whether you can train it to do certain specific functions. So that's a little bit like classical AI, um, but that is also more and more being called neuromorphic computing. Neuro from nerve, and morph means shape. So representing and building computers that reflect the shape of the neurons or the way the neurons work. Um, that I would say is the difference.
Okay. Amlan, I'm having such a good number of questions. If I tell all this, then I'll have to tell you good evening, and you'll have to tell me good morning. Okay. So here I'll have to do some selection.
Sure,
Okay, I'll try to pick up some questions which would be more relevant to this
sure,
session and more beneficial for everyone.
sure.
Abhinandan Chakraborty is a student of class 11, Don Bosco Park Circus. He has a question that which one is better? I mean, he's in class 11, so giving SAT and going to USA for doing the undergrads and grads, or doing giving the IIT JE and then after doing the graduation to go there and masters and all. So, like,
Yeah, yeah. Um, this is again a good question, but the answers are depend on a lot of factors. So, like I said, admissions to colleges like IIT are very hard, and through a competitive process. So there is the difficulty of that. The difficulty of that. SAT is a relatively easier exam, but SAT will not necessarily guarantee you admission into any university in the US. You, after taking the SAT exam, you will have to apply to the schools. You will have to select the schools, and you will have to apply to them. Typically, if you choose your schools properly, I mean, again, it may be hard to get admission into universities like MIT and Stanford, but there are a large number of very good schools that do not need to be MIT and Stanford, right? They're very good schools that you can go to and study and get a very good education. So your chances of getting admissions into a very good school is higher if you take SAT and come to the US. But there is a huge expense associated with that. So typically, you would be spending something like 40,000 to 50,000 US dollars a year for 4 years. So that's a kind of budget that you need to be aware of.
yeah, exactly. I think that is more safe option if your fund permits, isn't it?
Yeah, of course, of
Because
course.
cracking it easier to give SAT and score well and to go to USA than to crack IIT and doing
Sure,
undergraduate here.
sure.
But it all depends on your financial strength and this.
Right.
I have another question from a parent actually, and the parent, he was actually in USA, in programming only he was. And he has a question, Mr. Arijit Paul, that what is the scope of data science assignment globally? I mean, what is the demand, global
Um,
respect? What is the scope of data science assignment globally?
Quite large, especially I would say in the finance industry. So if you think of working in, finance and insurance kind of industry where there is large scale prediction that is necessary, right, for planning, forecasting, and so on, that's where data science is the most used right now, which are generally very high paying segments of the industry as well.
Okay.
So think like stock exchange and consultants that do financial planning and those kind of things.
Okay. A student Rishiraj Chaudhary of Don Bosco, he has a technical question. Uh, he is saying that is it possible to increase the computing speed of our current hardware by large factor, or has it already reached close to the maximum speed?
Yeah, good question. Actually, speed can be measured in multiple ways as well. One is the clock frequency of the processor itself, how fast the clock is triggering. So, if we talk about the clock frequency, that is more or less reached its peak. That is not going to keep increasing by many factors very quickly, if at all. But speed can be measured in another way also, that is the rate at which a computer produces output. And that can be increased a lot by having multiple parallel computers running at the same frequency. So you have a 1 gigahertz processor that produces output every 1 over 1 gigahertz, that is every nanosecond. But then if you have 10 of them, then you have 10 outputs every nanosecond. So you can increase the speed of that system by having many parallel computers. That's one of the ways in which actually I design computers in my multi-core work, multi-core architecture. A single chip or a single processor has many processors or many cores in them, and that's how we increase the throughput, what is known as the throughput or the rate of producing output, without increasing the frequency.
How that will become cost effective in terms
That
of,
will, yeah, that is costly, but it is not as costly as you would think, because making transistors using semiconductor processes is actually rather cheap. Area of silicon is not that expensive.
okay, okay. Uh, this is, you will love to have this question. Ayush Shah of Don Bosco, very good student, very good. So he wants to know, could you share some advice for cracking IIT JEE?
Yeah.
You have to memorize now that what did you do that time?
What I remember is that I worked really hard. I really, really worked hard right from day one. After my 10th exam, that summer vacation, I subscribed to what, I don't know if it still exists, Brilliant Tutorials. They used to send books of reading materials and examples and then question answers. I used to religiously solve each segment of their course material, send them solutions. They used to grade them, give feedback. That service used to be really good. I don't know how it is now, or whether there are equivalent similar services. So because your board's textbooks are not enough to crack an exam like that. In addition, my private tutors were a lot of help. I actually pushed them to teach me how to take IIT kind of exams, because those are above and beyond what you do in your school, much harder than what you do in your school, to be frank. So I worked really hard and I enjoyed doing that. I really enjoyed physics and mathematics. Chemistry, not so much. Chemistry was my nightmare, but physics and maths I really liked, and I studied really hard. I used to get up early in the morning, study, and yeah. Then I can give you some non-diplomatic advice as well. Sometimes I used to not go to school so that I can stay at home and study for the
That's required
entrance
actually.
exam.
That's important. Really, that's important. That's why nowadays students are looking for the schools for doing class two where the attendance is not compulsory.
Right, right, yeah, because it takes that much effort to do well in an exam like that.
Exactly. Uh, Here is one question that that is. Let me pick up. Actually, there are so many. No, I'll have to pick up the
Sure.
most good one, which would be important for everyone. Actually, so it is from Dept
Just I
only.
wanted to mention, Tribedi sir, for today I have
Yeah.
5 more minutes. I have another meeting at 11 a.m.
Okay. Sure.
But
Sure.
I am happy to, have this session once more, or whenever you have time. I'm happy to come back and interact and take more questions. So, as we wrap up today, just keep that in mind. I'm very happy to come back and talk.
Yeah. Fine. Fine. Thank you. So in IST, like 9:30 will close, isn't it? So we have
Yes.
5 minutes there. Fine. Just basically, I think uh, last question. So uh, the question which I'm picking up is from the Dept only. What is the difference between, it's very general question, difference between machine learning and AI?
Yeah.
So,
There is not that much difference. Sometimes these terms are used interchangeably. Machine learning or machine intelligence typically refers to algorithms and computers and so on. Artificial intelligence sometimes includes understanding the human brain and how to make computers kind of like the human brain. Um, so the difference is again very blurry. But artificial intelligence can be making something else intelligent as well, not necessarily only computers. Machine intelligence typically refers to computers and algorithms and so on.
right, Amlan, as you were saying, your preparation for JE, IIT, I just remember, with due respect, let me recall the name of Sudip sir for physics,
Yes.
and for chemistry, New Alipur, that sir,
Shutroshil sir.
Sudip
Shutroshil.
sir, right?
Yes, yes, yes.
So as we like have the information that these two teachers were actually very beneficial for your success.
Indeed, indeed.
So
I should mention Shudip Chattopadhyay. At the time, he was
right.
teaching at Vivekananda Mission School for physics, and Shrutoshil sir. I think he was a private tutor. Professionally, he
Yeah,
only
yeah.
taught
Still,
privately out of New
yeah.
Alipur for
Till now he
chemistry.
is doing.
Yeah, he revived my chemistry. My chemistry was I was really weak in chemistry. So he saved me because there is no hope in doing well in IIT without doing well in chemistry. And for mathematics, I went for tuition to a teacher whose name was Rajiv Mitra, also in New Alipur. But unfortunately, he passed away a few years ago. He got really sick with some kind of blood sickness of the blood. I was very heartbroken. He actually really helped me become very strong in mathematics. Unfortunately, he's not anymore. But like I said, I should mention these people who have had such a deep impact on my life.
Yeah, I think that it is our like basic duty to remember those persons who were instrumental for making our careers. So I do remember
Indeed.
in my case, and they were my colleagues, and then I have deep regards and respect for them because they did such a commendable job, and that's why the students like you were produced through their hands. So so
Indeed,
nice.
and not to forget you yourself, sir, because I wasn't that good in computer programming as such before you helped me with the programming aspect really.
Regarding you, just in a word, I'll tell you that from that time, I noted that the term, the optimization was very much with you. Okay.
Oh,
Because I was trying to recollect that what was your like specification, characteristics, features of doing program. So just that term came that if something would be written in 5 lines, you will never go to 6 lines. So actually that is now termed here, coined now as optimizations, okay, in
sure,
every field.
sure.
And optimization is a very generic term, which is should be there for in our life,
Everything,
in every
yeah,
job.
in
So
everything,
that
yes.
I noted with you. So people might say that optimization is to find a shortcut. Fine, that is never wrong. If you don't compromise with the output, then if you
Sure,
find a shortcut, what is the problem? Isn't it?
sure, sure, sure.
So, anyway, so we'll conclude the session. Okay. So, Amlan, thank you so much. Okay. For this wonderful session. Okay. I think many students were inspired seeing you, following your lectures. Okay. Hope they will be following your path. Okay. And
Yes,
in a future,
and I want to thank many of them have thanked me and said very good things in the comments. I read all of them, so I want to thank
yeah,
all
yeah.
of them as well. Yeah,
And it's
very
our
kind words.
apology that we could not address all the questions.
No,
Okay.
certainly, and I'm
But
happy to come back again. In fact, as a matter of
yeah,
fact,
yeah,
I was
surely,
saying
surely.
that I traveled to India in 2020 February to 4 cities to interact with school students like this in person. Partly from an RIT point of interest to have students come to RIT for their studies, BS bachelor's degree or graduate studies. So next time I do that, hopefully with COVID, being taken care of with the vaccines, if I go back in 2022 or any of those times, I'd like to come to your place
You can
and meet
have,
the
yeah,
students.
direct sessions, right? Direct
Yeah,
sessions, right?
I'll be very happy to do it.
Yeah, we can arrange that. We'll be having the halls. And regarding this online platform meeting, now they'll be appearing for the final term examination in the month of February and March.
Oh
So
yes, yes,
possibly in the month of May, if your
sure,
time permits, we'll be
absolutely,
organizing another one so that they can again join freely with their queries and this.
no
Okay.
problem. Let's keep in touch,
So
Trivedi
yeah,
sir.
yeah, my
Thank you
privilege.
very.
Okay. So thank you very much.
Bye
Okay.
everyone.
All the best. Bye. Bye. Everyone. Okay. Bye.